In this video, we're going to look at the definition of base unit vectors. We define a vector I as a unit vector in the direction of the positive x-axis. So I is a unit vector. A unit vector is a vector of length 1 unit parallel to the x-axis and in the positive x direction. We also define another unit vector, which we call j, to be a unit vector. Remember, this means a vector of length 1 unit, this time parallel to the y-axis and in the positive y direction. There are many uses for our base unit vectors. Here we have a point. We want to describe its position relative to the origin O. This type of vector is called a position vector because it describes the position of a point. Position vectors are equivalent to coordinates. If this point is O and this one P, we would describe OP as being 5i, since we go 5 units across, take away 2j, since we go 2 units down. We could also write this as a column vector 5 minus 2. If we now consider this point, which we'll call Q, a position vector to describe the position of Q would need to go 3 units backwards, so this would be minus 3i, and then 4 units upwards, so 4j, or as a column vector, minus 3, 4. So remember here that both OP and OQ are position vectors. They describe the position of a point. As a second use for these vectors, consider moving triangle A to triangle B. We need to go 3 units across and 4 units up. So we can describe going from A to B as 3i plus 4j, or as a column 3, 4. In this instance, we're using vectors as translation vectors. 3i plus 4j describes how we need to move triangle A so that it's in the position of triangle B. If we wanted to go the other way, from B to A, then quite simply we would go minus 3i minus 4j, which is the reverse journey. As a column, this would be minus 3, minus 4.